Alright, in this video we're going to do a little bit more with section 5.6, and it's going to be playing the matching game and also coming up with an equation of a rational function using some properties of rational functions, their roots, and their asymptotes. So we're going to look at the multiplicity's effect on a rational function after factoring and reducing. So here we are going to stay away from having any sort of holes in the graph. And what we're going to do is, for the problems we're going to look at, we're going to be looking at either the degree is going to be 1 or 2, or the multiplicity of the factor is going to be 1 or 2. So for the numerator, you're going to be looking at after you factored and reduced, and so the roots of the factors in the numerator, those are going to be your x-intercepts. So if you have an odd multiplicity, so for us that's going to be the first power, your graph is going to cross at that x-intercept because there's actually a sign change that occurs at the x-intercept. If you have an even multiplicity, so that'll have an exponent of 2, you're going to have a bounce, so it's either below and bounces from below on the x-axis or above. Just kind of depends on what the graph's looking like. There is no sign change at that particular point. For the denominator, if you have an odd multiplicity, your vertical asymptote, you're going to have one side goes up, one side goes down, or the other way, one side goes down, the other side goes up. So we're looking at a multiplicity of 1. If you have an even multiplicity, then both branches are going to go up, or both branches are going to go down. We won't get too heavy into it. It's more of, here's the graph of a rational function. Can we come up with a possible formula for it? And they'll keep things pretty basic. So let's go ahead and try this out on a couple of rational functions. Okay, so here is our rational function. There's the graph of it. And then we're going to come up with an equation that represents that. And so we'll look at our vertical asymptotes and our x-intercepts and the behavior there. Okay, so for my vertical asymptotes, I have one at -3 and also at 4. And notice that one branch goes down, one branch goes up, one branch goes down, one branch goes up. So when we write our equation for our vertical asymptotes in the denominator, they're all going to have an exponent of 1. Okay, so if -3 is the vertical asymptote, the factor is an x plus 3 in the denominator. And if 4 is the vertical asymptote, then x minus 4 is the factor in the denominator. Because they have the down and up behavior, it'll be to the first power. So you got that going. I'm going to go ahead and also mention the horizontal asymptote. It appears to be y equals 0. Now you don't really see it, but you do see at the end there it seems to be flattening out. So that means that the horizontal asymptote is 0, which means the degree of the bottom needs to be larger. So we'll keep that in mind when we come up with our equation. And then finally, our x-intercept happens at 3, 0. So the factor that goes with that is x minus 3. Okay? So the way I have it written, the top is degree 1, the bottom is degree 2, so that tells us our horizontal asymptote is 0. That's good. The other thing to maybe check to see is the y-intercept, and is the y-intercept reasonable here? So the y-intercept looks pretty close to 0, maybe like a quarter or third or something to that effect. So we'll go ahead and plug in 0 in and see what we get to find that y-intercept and see if that's reasonable. So it'll be -3 over 3 times -4, and so that is a quarter. And so that is a reasonable formula for our rational function there. So they're going to keep it pretty basic. So what we've done here, that'll be enough. Okay, so we're going to look at another. I think we got two or three more. So let's take a look at another one. Okay, so we're going to do the same thing. We're going to write the equation of the rational function. We'll first find our asymptotes, and then our x-intercepts. Okay, so your vertical asymptotes appear to be -3 and then 4. And now at -3, you see one goes up, one goes down. So that means the exponent's going to be 1. At the 4, you see how both are going up in the same direction, so we'll have a square on that factor. Okay, so in the denominator, the factor for the -3 will be x plus 3, and the factor for the 4 will be x minus 4. And because both branches are going up, we're going to get a square. Okay. All right. So now we're going to do our horizontal asymptote. It does appear to be flattening out to 0 in both directions, which means that the degree of the denominator needs to be larger. So horizontal asymptote is y equals 0. And then we'll go ahead and find that x-intercept 2, which appears to be at the origin. It's kind of hard to tell, but that's what it looks like. So that x-intercept is 0, 0. And so that'll give us a factor of x in the numerator. Now the degree of the top is 1, the degree of the bottom is 3, so that is bottom heavy. So that gives us that horizontal asymptote of 0. That looks good. And then we can go ahead and check the y-intercept, which is also the x-intercept that goes through the origin. And so we'll go ahead, and that gives us 0. So that looks good there. Okay, so we got x-intercept, y-intercept, vertical, and horizontal asymptotes, and so we come up with our equation of the rational function. Okay, let's go ahead and look at another one. So same thing here. I'm noticing vertical asymptotes at -2 and +3. It looks like we have one x-intercept at 2. Okay, so let's see what's going on there. So vertical asymptote at -2. And notice that we have one branch down and one branch up. So that's going to be, the factor is going to have degree 1, or multiplicity 1. And then at 3, you see that both branches are going up, so we'll have a square on that factor. Okay, so for our function, the factor that goes with -2 is x plus 2, degree 1, or multiplicity 1, and the factor that goes with 3 is x minus 3, and then that'll have a square because both branches are going to go up, no sign change there. All right, we do have one x-intercept, and I think we're probably going to do the horizontal asymptote first. Okay, horizontal asymptote, notice we're flattening out and flattening out, so it's going to be y equals 0. So when we're all done, we just got to make sure the degree of the bottom is larger. So y equals 0. X-intercept is going to be at 2 and 0, and that's the only one I see, and you do see that it bounces at 2, so that's going to cause it to have an even multiplicity, so there's no sign changes at 2. So you get x minus 2, and then we'll square that for the bounce there. The one last thing to see, is how's that y-intercept look? So we'll go ahead and plug in 0 and see. So the y-intercept looks to me like maybe a quarter or a third or somewhere to that effect, probably closer to a quarter. So go ahead and plug in 0 and we'll work that out. And so we'll have 4 over 2 times 9, so that's going to reduce to 2 over 9. That seems completely reasonable to me. And so that would be our equation of our rational function there. Okay, we're going to go ahead and look at one more here. So same instructions here. I look at both my vertical asymptotes at -1 and 5. They are both going different directions, so one of them is down, up. So we have a down and up, and the other one is up and down. Different directions, so both of those will be, both the factors in the denominator will be to the first power. And then we also have x-intercepts appears to be at 0 and also at 2. They are both crossing. And then the one thing that might be a little tricky is to get that y-intercept. I mean, not that y-intercept, but the horizontal asymptote. Okay, so vertical asymptotes, as mentioned, are -1 and 5. So our function here, factors will be x plus 1 and x minus 5. And because they are both going different directions, the branches there, they'll be to the first power. The horizontal asymptote is going to be y equals -1. That's going to be a little bit tricky. X-intercepts are going to be the origin 0, 0, and that gives us a factor of x. And then 2, 0, which gives us a factor of x minus 2. Okay? Now the one thing that's going to be a little bit tricky here is you see my horizontal asymptote at -1. So if we imagine that we multiply this out, this would be x squared minus 2x over x squared minus 4x and minus 5. Now, in order for this to have a horizontal asymptote of -1, the quotient of the leading coefficients must be -1. Right now, they are 1 over 1, which is positive 1. So all we need to do here is introduce a negative there. And there you have it. And then that would be your equation of that rational function there. Okay, so this one a little bit of a shorter video, and we'll see you next time.